Okay, table and chain. So you can write this heading: work done in pulling the chain against gravity. Work done in pulling the chain against gravity. Okay. So suppose if the chain length is L. Okay, chain length is L. Okay, we have got a chain of length L. Mass of the chain is going to be M. Mass of the chain is going to be M. Now mass per unit length, mass per unit length is total mass divided by L. Okay, so suppose if this one so mass per unit length, for a unit length how much is the mass is small m. Suppose if we consider a case like this. This is a table, okay, a chain is there. Okay, so if the total length of the chain is L, then L by N, okay, L by N of the chain is hanging. Clear or what? Okay, so this is the situation. This is the situation. Okay, clear or what? This one. Okay, now what we are going to do is, how much is the work done in pulling this chain against gravity? Suppose if we want to take it onto the table, or how much is the work done if we want to bring the chain down. Okay, now suppose if we consider this point, this reference, if we want, we can consider like this is the potential energy. Here it is 0. Some reference point we will be taking as 0. Okay, so then if this is L by N, then the center of mass for all these things, the problem is we cannot say like a ball is at a height mgh likewise, because this is a continuous body, not a point body. So if the center of mass is here, we can say that the center of mass is located at L2N. Correct or what? The center of mass is located at L by 2N. Now suppose if we want to pull the chain against gravity, means this is how the gravity will be acting like this. Correct? What is the potential energy here at this point? What is the potential energy at the center of mass? Can you tell?
L by 2N.
Capital mgh is the formula. For this unit length, the mass is m by L. For this unit length, mass is m by L. So I could say mass of L by N chain, mass of L by N length chain is going to be, unit mass is m by L into, this is for 1 unit, into L by N. So this is the mass actually. So the energy, the potential energy present in this chain, or the work done in order to bring the chain up, will be mgh. So we can write one formula like m by L into L by N. We will cancel this. Okay, wait it. Into G. Into what is the height I should take? L by 2N. So this is the work done. This is the work done. So what I could write? So work be, if we cancel this LL, then MGL divide by 2N square. Okay, understood or what? So if you know what fraction is hanging, you can directly apply that N here. This is nothing but total mass of the chain, total length of the chain. Okay, half of the length is hanging out, half, L by 2 will come here. 3 by 4 is hanging out, means 4 by 3 you will have to put here. Correct or what? Because I have taken here L by N. Correct? Clear or what? Done. Okay, take down this one. I will give one more formula. Completed. Shall I erase this? Sudarshan, தூக்கம் வருதா? ஏன் சுதர்ஷன் தூக்கம் வருது? சுதர்ஷனை தூக்கத்திலிருந்து எழுப்புறதுக்காக என்ன பண்ணலாம்? எல்லாரும் சேர்ந்து ஆலோசனை. பிரேக்கா? சுதர்ஷன் போயிட்டு வேணா ஃபேஸ் எல்லாம் வாஷ் பண்ணிட்டு வாங்க. எல்லாரும் போய் வாஷ் பண்ண விடணுமா? அது என்னது? என்ன நியாயம் அது? Okay, the next is actually velocity of chain while leaving the table. Velocity of chain while leaving the table. Velocity of chain while leaving table. So suppose if this is the initial position, while leaving the table, this will be like this. Okay, this is how. So while leaving the table means the last end will be here. So while leaving the table, whatever be the change in potential energy, suppose if this was the initial position, so work done in the chain, that is the initial potential energy. Now if this thing is coming to this position, that is the another potential energy. So the change in potential energy of these two positions will be converting into what? Velocity or kinetic energy. So change in potential energy is the kinetic energy. So equate and find mv square, find the velocity, you will be getting the answer. So change in potential energy will be the kinetic energy. Correct or what? So suppose if this is the reference point, no, u is equal to 0. Now suppose the total length of the chain is L, then the position of center of mass is L by 2. Position of center of mass is L by 2. So the final kinetic energy, the kinetic energy of this one is mgh. So again m by L, it is the mass per unit length, okay, into what? L by 2. See, total m by L is the mass per unit length into how much the full length is hanging now. So we need not multiply with the m by L into L, and simply we can take the total mass. Now m g, what is the height? L by 2. This is the potential energy of this situation. Now change in potential energy is mgl divided by 2n square minus mgl by 2 is equal to half mv square. So 2 m will be cancelled off. Second that is not mgl by 2 is there, will be cancelled. Okay, m is cancelled. Correct, thank you. So this is going to be what? V square is equal to L GL, okay, GL, this is going to be 1 by n square minus 1. If we take root, this will be the velocity with which the chain is going to come down. What is that n? The initial position, a fraction of L will be hanging. So L by how much? That number you can give there. Clear or what? Understood? கிளாஸில் இருக்கும்போது தண்ணி, பிஸ்கட்டு, சாக்லேட் அதெல்லாம் அப்படியே கையில் வச்சுக்கணும். இடையில தூக்கம் வரும்போது அந்த பிஸ்கட் சாப்பிட்றது, தண்ணி குடிக்கிறது, இடையில சும்மா என்ன கூப்பிட்டுட்டு என்னோட தூக்கத்தை மாற்றுறது, இந்த மாதிரி என்ன இருக்கணும்? ஸ்நாக்ஸு எல்லாம் இருக்கணும். அதே மாதிரி கண்டிப்பாக புரிஞ்சு படிக்கணும். ஓகே, அண்டர்ஸ்டாண்ட் அண்ட் ஸ்டடி. அப்போ அவ்வளோ தூக்கம் வராது. எங்கேயாவது இஃப் யூ டோன்ட் அண்டர்ஸ்டாண்ட் யூ ஷுட் ஸ்டாப் அண்ட் ஆஸ்க். அங்கே கேட்கலன்னு வச்சுக்கோ, அப்புறம் ஃபுல் டே தூக்கம் தான். கிளியர்? ஸோ question number 48. எழுது. Okay, question number 51. Come to question number 51. Question number 51. Question number 51. A uniform chain of length. A uniform chain of length 2 meter is held on smooth table and 1/3 of its length is hanging vertically down over the edge. Okay, over the edge. Over the edge. Then over the edge of the table. If G is the acceleration due to gravity, the work required to pull the hanging part onto the table. Okay, easy question, no? Okay. Direct application of this formula you can do. Just put n equal to 3. Okay, so getting all of you. So this question, this formula, question number 51, the formula is W is equal to mgl by 2n square. What is the mass of the thing? Okay, everything is given. mgl divided by 2 into how much is hanging? 3. 1 by 3, L by 3, so it's going to be 9. Okay, so mgl by 18. Kanda. Super. Students are very brilliant. Chance illa. சும்மா சொல்லி கொடுக்கிறது ஒரு வாய்ப்பே தரது இல்ல. அதுக்குள்ள ஆன்சர் சொல்லிடுறாங்க. Chance. Question number 55. Come on. A chain is placed on a frictionless table with 1/4 of it hanging over the edge. If the length of the chain is question number 55 la. In the question 52. Question number 52. A chain is placed on frictionless table with the 1/4 of it hanging over the edge. If the length of the chain is 2 meter, mass is 4 kilogram, then energy need to spend to pull it back on the table. Okay. இந்த கொஞ்சம் ஒரு 1 hour முன்னாடி முதல்ல இந்த क्वेश्चन கொடுத்துருந்துருக்கோம். அப்போ தெரிஞ்சிருக்கலாம். பண்ணுவாங்க எல்லாருமே பயங்கர கொடுத்து வச்சிருக்கணும். இந்த மாதிரி குழந்தைகளை பார்த்ததே இல்லை. So 1/4 is hanging. 1/4 is hanging. So this is how much? இங்க 1/4 போடவா? 4 square. Okay. 2.5. Oh, 2.5 joule. Children, good. அடுத்த question. இது question number 52. Question number 53. Come on, fast. A uniform chain of length 2 meter is held on smooth horizontal table so that half of it hangs over the edge. If it is released from rest, the velocity with which it leaves the table. மதுமதி அல்ல இந்துமதி நான் கூப்பிடவே இல்லை மதுமதி நான் சும்மா சொல்லிட்டு இருக்கேன். So V is equal to what? Children, this one, root of GL into 1 minus n square minus 1. So what is plus 2 and this is going to be 1. How much? 1/4 minus 1. Correct or what? So what you are getting? Okay, right. This is going to be 20 into 3/4. We will be getting root 15, right? Root 15. Please ignore this minus sign here. If you want, you can. I have taken the difference from smaller minus bigger. That is why the formula came like this. If a greater minus less, if I do, I will be getting 1 minus 1 by n square. Understood or what? இங்க நீங்க போடும்போது 1/4 minus 1 ஏன் வந்திருக்கு? Because I have taken u lesser minus u greater when I take that potential difference. அதனால மட்டும்தான். So அதனால கன்ஃபியூஸ் ஆக கூடாது. Root 15 எவ்வளவு இருப்பா? What are all the options? 2, 4, 6, 8. Take 4 bus. Okay. Done. டைம் எவ்வளோ ஆச்சு? 5க்கு முடிச்சிடலாம். அது போதும் இல்லை? 5:30 முடிச்சிடலாம். இல்லை ஒரு 5:15 முடிச்சிடலாம். இப்போ பிரேக் எடுத்துச்சுன்னா மறுபடியும் 1 hour எடுக்கணும். 6 o'clock வரைக்கும் எடுக்கவா? நானா? ஓகே, we started at 3 o'clock இல்லை, இப்போ 4:30 தான் ஆச்சு. 2:30க்கு வரவே இல்லையே, ஆஃபீஸுக்கே வரல. ஒரு half an hour கூட அப்போ ஒரு நல்ல செஷன் கிடைக்கும். அதான் நான் இப்போ போனீங்கன்னா I will start sleeping. அடுத்த question children, see இங்க வந்து question number 49 to that 50 that you will do, no? 49, any confusion? 49. Question number 48 another. Work done in making it stand on one end. Correct தானே? mgh தான், but mg L/2 center of mass பாருங்க பஸ் over. Next one. Just resolve that into vector. Resolve that length into horizontal and vertical. How much is vertical? That is the, how much is the change in height? That will be the, so the answer will be getting A. Question number 49 will be getting A. Okay, right. Now 50 till 53 we have finished. Now come 54 children. 54. 50. Once a choice is made regarding zero potential energy reference state, the changes in potential energy. Once a choice is made regarding zero potential energy difference, the changes in potential energy means if you are taking a reference as zero potential, just like we have taken now. Generally where we will be taking the potential energy, we will be taking the potential energy from ground will be zero. So in the previous case we have taken this as potential energy reference is equal to 0. So if we take like this, will the result of potential energy will change? If the value of potential energy will change, then this concept is wrong. No, we cannot take like that. It will not change. Only thing is why we have taken like this, because it will make our task very easy. We will be able to solve the problems very easy. That is why we have taken the potential energy like this. If we take some other reference point as zero potential energy, still the answer is going to be same, because we are finding change in potential energy. Okay, so the answer for that one are same. 50 will be A. Okay, next one. 54. Two stones each of mass 5 kilogram fall on a wheel from a height of 10 meters. See, we are almost finishing all the concepts of energy. Okay, just kinetic energy, all the aspects of potential energy. Okay, now the remaining topic will be power and collision. So collision we have to discuss a lot. Okay, if we need to discuss very peacefully, then only we will understand that collision is a vast topic finished in 2 pages in NCERT. Okay, it is a vast topic. It is just like a full subject. We can take even 8-9 hours also. Okay, but we will try to make it concise, but there are some contents. Okay, leave it, come back. So 2 4 meter. The wheel stirs 2 kilogram water. The rise in the temperature of water would be. Two stones. So what is the heat? We have already seen. What is the energy or heat required to change the temperature of something?
MS
delta T. Bus over. So what the question number is? 54. So MS delta theta is equal to 2 stones. mgh plus mgh, 2 mgh. Okay, so this is mass of the water, this is mass of the water, this is mass of the stone. Clear? Done. Mass of the water is 2. Mass of the water is 2. Specific heat capacity of water is that 4.2 into change in temperature we need to find. This is equal to 2 into what is mass of the stones? 5 into 10. The height 10 meters. So if you do this, okay, delta theta, the change in temperature is 500 divided by 4.2. How much?
4.4.
Okay, this is for gram. So this is actually 10 raised to 3 is there. You need to multiply here 4.2 into 10 raised to 3. So this is for gram 4.2 joule per gram per degree centigrade is what is 4.2. Specific heat capacity of going to be what? Per gram per degree Celsius. So we need to convert this into for kilogram. Here what will come? 10 raised to minus 3 will come in the denominator. So in the when it comes to the numerator, 4 into 10 raised to 3. So this is going to be 10 raised to 3. How much? 0.12 degrees Celsius. 0.12 degrees Celsius. If it is difference, it is degree Kelvin also. Same degree Kelvin also fine. Clear? Anyone? Any doubt in this? At the question 55. 55. Question number 55. A boy is sitting on a swing at a maximum height of 5 meters above the ground. So this is at a height of 5 meters. So this swing comes to this position. When the swing passes through the mean position, which is going to be 2 meters above the ground. So the velocity will be approximately, what will be the velocity? So whatever be the change in potential energy will be converted into kinetic energy. Okay, so mg, suppose this is h2. Suppose if this is h2, this is h1, then we can say mgh2, that potential energy will be converted into mgh1 plus half mv square. Correct or what? The potential energy that was available here, it is converted into, when it is coming like this, converted into this kinetic energy plus here whatever be the potential energy, that one. Okay, so this is going to be mm will be cancelled off. What we need to find? What is the velocity? So g into h2 minus h1 okay, into 2 root. This is the velocity, that is 2 into 10 into 3. Root 30, yeah? Root 60. Root 60. So answer will be 7.6 meter per second. Correct? What is the option? A. Next question number 50. 54 board liya. 56. This one was? This is 55. Okay. So 56. So 56. A block of mass M slides of a ball as shown in the figure. Figure is there, no? Yes. The walls of the ball are frictionless, and but the base has coefficient of friction 0.2. If the block is released from the top of the side, which is 1.5 meter high, where will be the block comes to rest? Length of the base is given 15 meter. Okay. So what to do? Okay, so a mass M which will be sliding like this, and it will come and it will stop somewhere. Okay, so this height is given as how much? 1.5 meter, and this length of the base is given as 15 meters. 15 meters. So this has a coefficient of friction 0.2. Coefficient of friction 0.2. Okay, so what will be the displacement, or how much will it travel in this distance? Okay, so enna pannalam, this is going to be mgh. That full potential energy should be eaten by whom? Friction. Inga kinetic energy la kandupidikanuma? Not required actually. This full mgh, this potential energy will be okay, will be wasted as the work done against friction. Correct or what? So this is, what is the friction? Mu mg into this s. How much distance it will cover? That is s. Correct or what? Yeah. Answer 1.5 divided by 0.2. Then our answer 7.5 meter. So option B. Option B. So this total length is given as 15 meter. So exactly at the midpoint, that is at S is equal to 7.5 meter, will stop. Is it clear pa? Puriyala. This is a mass. We are just dropping it. So what will happen? This will come. It will come like this. Here this potential energy will be converted into kinetic energy. But after that also this will move further. Okay, this will convert into full kinetic energy. Then this kinetic energy will be converted into what? Work done by friction. So in between, if we want, we can do something in kinetic energy, but it is not going to help us. So what we can do is this full mgh will be converted to work done by friction. So mgh is equal to Work done by friction means frictional force into displacement. Frictional force is mu mg into s. S kandupidicha podume. Kandupidichachu half of the midpoint of the PQ. Okay va? Bas. Any doubt in this? Anyone? Doubt irka? Apuram marubadiyum enna? Mokathil oru idu. அப்படி போட்டால் இன்னொரு ஸ்டெப்பு கூட சும்மா ஒரு 1.5 மினிட் என்ஜாய் பண்ணலாம். mgh is equal to half mv square போடுங்க, அப்போ அவங்க ஒரு வெலாசிட்டி கிடைக்கும். அப்போ ஆன்சர் வந்தது ராங்கா?
இதுதான் சார் வரும் அப்படி
இது இந்த ஆன்சரா? இதுவா? mgh is equal to half mv square, so v is equal to 2gs, 2 into 10 into
1.5 distance
1.5, so upon the root 30, so root 30 is equal to
5.5
root 30 is equal to mu root 30 is equal to g. So mass கொடுக்கவே இல்லையே. இப்போ இந்த ரூட் 30 என்ன வெலாசிட்டி தான். அப்போ சரி போடுங்க, half v mv square is equal to half into m into 30 ன்னு போடுங்க, is equal to mu mgh, mu mg into s ன்னு போடுங்க, mu mg into s. இனி mm கிளாஸ் கேன்சல் பண்ணிக்கோங்க. ஓகேவா? இப்போ இனி சப்ஸ்டிடியூட் பண்ணி பாருங்க.
சார் அந்த h வந்து h plus and s ஆட் ஆன ரெண்டுமே எடுக்கணும் சார். இந்த மாதிரி போட்டா
இந்த மாதிரி
UG h க்கு பதிலா h plus s எடுக்கணும்.
ஆனா h க்கு ஃபிரிக்ஷன் இல்லையே.
இங்க வரைக்கும் பொட்டன்ஷியல் எடுத்து வெலாசிட்டி கண்டுபிடிச்சிட்டு
இது போட்டு பாருங்க, வாட் யூ ஆர் கெட்டிங் s வேல்யூ. मैं गुड रहा हूँ जोशो வரணும்ல. இப்போ சமயம் தரேன் 445 அப்போ இப்போ விட்டுட்டு
இல்லைன்னா கண்ட்ரிஸாக எடுத்துக்கங்க, 530 எடுப்பேன்.
ஒரு ചെറിയ ബ്രേക്ക് 10 മിനിറ്റ് കൊടുക്കാമല്ലേ? കറക്റ്റാ? ഓക്കെ. See children, the thing is one question was like half mv square. So from half mv square, again if we find it out, what is wrong in that? Nothing wrong in that. ஒரு extra step போடலாம், தப்பில்லை. ஒரு extra step போடலாம், just verification that the concept is clear. Extra step போடும், கொஞ்சம் டைம் போகும். But while studying, you should analyze like this. இங்க போட்டு mg, you can do like that. You have time now. Verification எல்லாம் முடிச்சதுக்கு அப்புறம் nothing will affect there. அப்படி பக்கா புரிஞ்சிச்சுனா then in the exam you can do directly shoot it. Okay, so nothing wrong in that. You can பண்ணும்போது தவறு ஆயிடுச்சுனா you can ask like this. புரியுதுங்களா? Now it is correct. No, ஒரு மனசுக்கு ஒரு நிம்மதி, ஒரு சந்தோஷம், அதான். Okay, so verify everything. Okay, concepts are correct. Wherever problem is there, you should verify that. Okay. Okay, question number 58. A 2 kilogram block is dropped from a height of 0.4 meter on spring of force constant K is equal to 1960. The maximum compression. So this is just like a spring is there. Okay, a spring like this. Okay, a spring like this. What is happening? A 2 kilogram block, if it is dropping like this, finally what will happen? There will be a compression for this. So the work done on spring is what? Half kx square. So this half kx square, the work done on the spring is from which source? from the fall of this 2 kilogram mass. At what height this is? Dropped from a height of 0.4 meter. So that is the height. So here this has got a potential energy of mgh. So when this is fallen to this one, when this fell to this one, maximum compression will happen. Its potential energy will be converted into the work on this spring. So we can write half kx square is nothing but mgh. What they are asking, how much is the maximum compression? So x is equal to 2 mgh divided by k root. So 2 into 0.4 into what is k? 19600. Hey, 1960 into this is going to be 10. What is the mass? 2 kilogram. So this is how, right? 2 into 10 into 0.4 into this. How much you will be getting, children? Around 0.1 meter will be getting. Around 0.1 meter will be the answer. Okay, so now just look at the concept, calculation we can manage. Next is question number 59. Question number 59. Figure is given. A block of mass 2 kg is released from A on the track, that is 1 quadrant of a circle of radius 1 meter. So this is how it is. Correct? Okay. Okay, so this is A and this is B. So this is 1 meter, 1 meter. This is just like a quarter of the circle. That is what they are saying. So a mass of 2 kilogram is released from A, and on the track, that is 1 quadrant of the circle of radius 1 meter, it slides down the track, reaches B with a velocity of 4 meter per second. So here its velocity is 4 meter per second. Okay, finally stops at C. Okay, let this be C. So here the velocity is 0. This distance is given as how much? 3 meter. So it stops by itself. So what they are asking is, what is the force against the force of friction? The work done against the force of friction. Clear? So first, initially it has got a potential energy mgh. Okay, so total energy goes against friction here. Total potential energy goes against friction here. So the thing is, coefficient of friction is not given. So whatever we do with the mu, mg and all, we are not going to get the answer. Okay, it stops here, right? It stops here. So whatever be the thing here, this is 1 meter. So here the potential energy is what? mgh is nothing but 2 into 10 into 1. 20 joule. This 20 joule is the work done against friction. Puriyudunga? Not? See, it is coming. It came here. What happened? Stopped there. So in the full potential energy is 0 here. The converted kinetic energy here, that also becomes 0 here. Who has eaten all this? Friction. So what is the question? Work done against the force of friction. This one adane irukum. Full potential energy is converted. So force, the work done against friction will be 20 joule. If this is stopping here, if it is not stopping here, we won't be able to comment. We will be able to say mu mg into that distance we will have to give. If it is coming like this, ingara tukuru agala, this is continuing like that, and this distance is given like a 3 meter, then mu mg into 3 we will have to find. Now this is patak, stopped. So potential energy is completely converted into this one. Done? Understood? The thing is like this potential energy is completely converted into kinetic energy here. So in this kinetic, whatever be the potential energy there, that will be the kinetic energy. Then after that, this is reducing. Then again it will come here and it will stop. So you will be able to put potential energy plus kinetic energy if it is here. Here no potential energy, only kinetic energy. Clear, children? Understood? Ini adutha question. A stone projected vertically upwards from the ground. A stone projected vertically upwards from the ground reaches a maximum height h. When it is at a height of 3h by 4, the ratio of kinetic energy and potential energy.
If we equate the kinetic energy alone, we are not getting the answers. Half m into 4 square. Then 16 joules.
Because the problem is like here this is not full kinetic energy. Understood or what? Because see, suppose if we take this as height, this height is equal to 0, going to be mgh. Now suppose if we calculate the kinetic energy here is equal to half into 2 into, how much is the velocity here? 4 square. So this is going to be 16 joule. 16 joule and this is going to be 4 joule. Maybe this must not be. See, if we are taking this as height is equal to 0, definitely what should come? 20 joule should come. So this is just like we can consider like this could be somewhere like this conceptually. Then only we will be getting 16 joule. Otherwise we should 20 joule there also. Okay, so if this and this is not equal, never try to equal this to this. Always give the preference to this. That is what. Maybe small, at least small height difference is there. Definitely full kinetic energy will not be equal to full potential energy.
So at that time this equal to the validness of what I wrote, because mgh is not 0 completely.
Yes, that is valid, but you should know this height. If you take an intermediate point, if you know that height, we can do that. They haven't given. They want to do it in 1 minute. If we try to do it in 10 minutes, not possible.
That curve will also have friction, no sir? So
no, that is not given in the question. A block of mass 2 kg is released from A on the track. Same track. Friction could be there, yes. Let it be there. Friction irukkalam. Same track na kuduthirukka. Okay. See, friction irukattum. Inga friction irundhalum kuda, it is not going to change anything. This potential energy is completely converted into work against friction. That's all. Okay, clear? Okay, think more, think. If you have any confusion, please again discuss all that. Okay, what is the question we are discussing now? Okay, any concern for this question? Anyone? See children, if you have any confusion, see if you have any confusion, you should ask that and we should discuss in the class. It is not like one person saying something and all the others are believing. It is discussion. Study of science should be based on completely discussion. Okay, certain things I will be telling something. If when you ask something, I will understand not that is not the case. Correct or what? Then I will correct it. There is no claim that whatever I say will be 100% correct. Okay, there will be mistakes also. Certain things we may not clearly look into it. Okay, certain concepts, when you show that, things will be clear. So whatever doubts you have, you can ask. Ask per as much as possible. We will be delivering what? Correct things. But if you want to know, okay, this potential energy, fine. Suppose if you want to know what is the happening here, when you try to discuss, we will get more interesting ideas maybe. Sometimes that may not be valid. We will leave it. We will come here. So likewise, if you have any doubt, please ask. Okay? Okay, clear? Kalayil or arumeyana doubt. Lot of things we studied, no? So adhe mari Mukesh avargal edo kettingilla inike koduthu vechirukonu. Okay, what question number 63, children? 60 60. Question number 60. Okay, so what is that question? A stone projected vertically upwards from the ground reaches a maximum height h. When it is at a height 3h by 4, the ratio of kinetic and potential energy is. Okay, so at a full height h, the potential energy will be what? mgh. So at a 3 by 4 height, okay, at a 3 by 4 h, potential energy is going to be what? mgh into 3 by 4. What they are asking? The ratio of and potential energy. So what is the potential energy at this height? mgh into 3 by 4. What will be the kinetic energy? 1 by 4. 1 by 4 of mgh. This is full Lilia. Correct or what? Bus over. Done. Chance I love. Okay, 1 by 3. Good. Another question, Tangams. So this is correct. Okay, question number 60. Right. Okay, so now wait. Okay, we'll go to the next topic. Next topic edukka vendama. Next topic is power. Now put the heading. Okay, next put the heading power. Okay, rate of doing work. Power is nothing but rate of doing work, or energy by time, or work by time. Okay. Suppose if the work, okay, at a different time, suppose T average, okay, suppose if we consider a small amount of work that is happening for a duration of time, delta W by delta T. Okay, some work we are doing. If this time duration is very small, what we do? P is equal to dW by dt. W is nothing but d by dt of F dot S. F dot S. So if this force is constant, then we can write d by dt of F. So power is equal to F dot. So this V is a vector, force is a vector, this is a scalar. Okay, so this is one formula for power, this is another formula. Okay, so power is a scalar. Okay, watt, kilowatt hour, kilowatt, all these are its units. Kilowatt hour is actually not the unit of power, this is actually unit of energy. We used to say horsepower also. 1 horsepower. 1 horsepower is 746 watt. Okay, or joules per second. Suppose if we have a work time curve like this, if you mark a point, if you draw a tangent here, we will be getting what? Slope. Okay, this slope gives us instantaneous value of power. mLt raised to minus 2, lt raised to minus 1, so m L square t raised to minus 3, dimensional formula. Okay, done. Okay, now come back to the handout. Question number 61. A car of mass m driven with the acceleration a along a straight level road against a constant external resistive force, when velocity of the rate at which engine of the car is doing work will be. So car ku mass irukudhu, mass m, okay, that is driven with the acceleration a, so that is there. Then there is a resistive force also, let it be friction or air resistance, whatever it may be, resistive force is there. Now if the velocity of the car is v, then rate which, what is rate at which engine of the car is doing work? Power. So question 61. So rate at which the engine of the car is doing work means nothing but this is power. Velocity is given, so power is equal to F dot V. F dot V. Okay, which option? D. What? D. Anyone is saying D? Okay, so engine of the car is doing work. So engine will have to handle what all? Mass into acceleration is a force. So I can write engine will have to handle what? Mass into acceleration. So taking into acceleration to that direction, that is there. Along with that, புரியுதுங்களா? Understood? Correct? R plus MA into V. What? Okay. So engine should work against whom? See? Also, so engine should do a load of work against R. What is also there? Bag is also there on the top. Car, MA. This bag wants to go with the acceleration A. Mass, MA. Who will have to carry this? Car. So that is there. This resistance is also there. So how much power this engine should have? Engine should have a power of beating this R, handling this MA. So that much work it will have to do. Correct? So I should have R force to that direction. I should have MA force also to that direction. Then only I will be able to take the car to destination. Clear or what? Preeta? Okay. Why F net is not taking? F net எடுத்து பார்க்கலாம் என்ன கிடைக்கும். இப்போ என்ன இப்படி ஆக்ட் ஆகுதா? ஆக்ட் ஆகுதா? If it is about to move, சும்மா நின்னுட்டு இருக்கு, மூவ் ஆகும்போது தான் friction will act. Okay, so அது வெச்சுக்கோங்க R. Okay, now this is moving with the direction M into A. So இப்படி எடுத்தா என்ன கிடைக்கும்? What do you get? F net நீங்க சொல்ற மாதிரி F net எடுக்க போறேன். F net இது இப்படி மூவ் ஆகிச்சுனா இது இருக்கும். என்ன ப்ராப்ளம் தெரியுமா? If only MA is there, because of this one, I will stop here. Once this MA is equal to R, what will happen? Both are force. F net is equal to 0. Sugam, Sandosham, Nimmadi, Ange irukum vandi. Breakdown aids. Understood? So that is a different concept. That is different one. Now we are analyzing how much strength this engine has in order to take the car to the destination. So this should have, along with the MA, if this has got R, then the brake, this will proceed. Correct? This person is opposing. So we should have a force equal to this one also along with MA in order to move further. Okay? Done? Fine. Innu question? The next question? 62. A pump motor is used to deliver water. Certain rate from a given pipe. To obtain twice as much water from the same pipe in the same time, the power of the motor increased. Okay. Okay, so to pump the water to a height, say for example, a pump will have to deliver water at a certain rate from a given pipe. So, yes, suppose if it is pumping to a height or from a height, then P is equal to work by time. This is equal to mgh divided by time. So same time they are asking to obtain twice as much water from the same pipe in the same time. Okay, so H, G, everything is same. Correct? Say how much times the water? Twice. So here P is proportional to M. Correct or what? P is proportional to M. So if we need to have twice the number of water, twice the amount of water, then obviously this will become 2M and this P will become 2B. So question, the answer is going to be option D. Bas. Question number 63. A force applied by an engine of a train of mass 2.05 into 10 raised to 6 kg changes its velocity from 5 meter per second to 25 meter per second in 5 minutes. The power of the engine. Okay, so power of the engine, question number 63. So power of the engine is equal to work by time is equal to change in kinetic energy by time. Correct or what? So this is half into mass is given as 2.05 into 10 raised to 6 into the velocity is 25 meter per second and 5 meter per second. So 25 square minus 5 square divided by time 5 minutes. So 5 into 60. That's over. Done. 2.05 megawatt. megawatt. This is question number 64. From a waterfall, correct Dana? From a waterfall, the water is falling at a rate of 100 kg per second on the blades of turbine. And the question Dana? On the blades of turbine. If the height of the fall is 100 meters, then the power delivered to the turbine will. Okay, so again same thing, nothing is there. P is equal to mgh divided by time. Okay, so this is the power delivered to the turbine falling 100 grams per second. So here the time is 1 second. This is going to be 100 kilo. 100 bus. So this is going to be 100 kilowatt. Clear or what? Okay, so from a height it is falling. Okay, that power will be utilized. Okay, done. Next question. 65. A particle moves with a velocity v is equal to 5i minus 3j plus 6k meter per second under the influence of constant force. F is equal to 10i plus 10j plus 20k. Right, the instantaneous power. So power is equal to F dot V. This is going to be 50 minus 30 plus 120. Okay, so 140 joules per second. Then next question, a car of mass 1250 kilogram experience a resistance of 750 Newton when it moves at 30 meter per second. If the engine can develop 30 kilowatt at this speed, the maximum acceleration that the engine can produce. Okay, so here power is equal to force into velocity. So what is the force actually? Resistive force plus what? Mass into acceleration. Resistive force plus what we can say? Accelerating force. Accelerating force plus into velocity. Clear or what? So this is the force. So resistive force how much is given? 750 Newton plus MA. So this into what is the velocity? 30. Then what they are giving? If the engine can develop 30 kilowatt at this speed, so this is going to be 30 into 10 raised to 3. If the engine can produce 30 kilowatt at this speed, okay, so this is the 30 kilowatt power, resistive force into MA into 30. So here mass is given, mass is also given, right? 1250. Okay, fine. So what MA is equal to what we'll be getting? MA is equal to finally we'll be getting 250, and acceleration is equal to 250 divided by 1250. What we'll be getting? 0.2 meter per second square. Clear? Next question number 67. Question number 67. Question number 67. A bus weighing 100 quintals. So 100 quintals means how much? 10 power 5. Okay, 10 power 5. 100 quintals means 100 into 10 power. Okay, see children, this is moving at a speed of 72 km per hour. The friction of the road is 9% of its weight, and that of the air is 1% of its weight. What is the power of the engine? So again, power is equal to the resistive force plus its weight, okay, its force of acceleration. So mass into what they are giving? Okay, mass into weight of the bus is mg. So power is equal to resistive force plus mg. Okay, they will have to handle these two, okay, into velocity. Correct? Now coming to the question, total friction force. What is the weight of the bus? Weight of the bus is mg. This is actually how much? 100 quintals. So 100 into again 100 into 10. This is equal to total weight mg. Correct? So how much will come? 10 raised to 5. 10 raised to 5 Newton is the weight of the bus. Now what we need? Friction force. resistance force is 9%, friction is actually 9% of the weight, and air resistance, what is given? That is 1%. So totally 10% of this weight is what? Resistive force. So 10% of this, 10 by 100 into this one. Okay, how much will come? So this is going to be 10% of weight. So we can say this is going to be 10 raised to 4 Newton. Correct? Clear?
100 into 1000.
100 into
1000.
this one.
Yes.
Mass is 100 quintals. Oh, you are saying like 100 quintals, 1000 kilo. This 100 into 1000.
No, sir. 100 into 1000 into 10. 10,000. 100. Quintal to
Okay, we'll settle, we'll see. Okay, let's put here 10 raised to 5, later we'll confirm. Okay, so mg is 10 raised to 5 Newton. Now this one is actually, okay, so this is going to be, how much will come? 10 by 100 into 10 raised to 5. If we do here, if we cancel, this will become 10 raised to 4. Clear? Resistive force 9% friction, 1% air friction. Clear or what? So this is going to be now power is equal to total force 10 raised to 5 plus 10 raised to 4 into how much is the velocity? 70 km per hour. So 72 into 5 by 18 to convert this into meter per second. So finally how much will be getting? Are we getting 200 kilowatt? $220. It is not there in the option. Okay, so this is coming as 220 or 200 kilowatt. Just check. This which one? 10 power 4 will not come.
The thing is moving with constant velocity. So we don't need to have to do work against acceleration because it is moving with constant velocity. So we can ignore 10 power 4.
Even though this what we are finding is actually instantaneous value of power. So at instantaneous value of power, just like in the case of terminal velocity we have seen now. So same way, this velocity is for that instant only. If the force is there,
The bus is moving with constant velocity. So
A is which one we have like see bus has got a mass. This bus has got a mass, that has got a weight. So what we will have to, this engine will have to do, this engine will have to carry this weight of this whole bus and passengers, and at the same time it will have to work against friction also. Understood or what? Clear? That is the reason. Why? Because see, this is just like this force into this velocity, this force into this velocity, so that we will be getting, power is a scalar. See children, see, look here, all of you, this force is acting in the opposite direction, mg is acting in the downward direction. So obviously F net will be different if we take the vector. But remember, we are trying to find power. So power is a scalar. So if you take it in a different way, power, in order to overcome the resistance due to friction and air resistance, that is one power, and power in order to take this load to the destination or to some distance. So these two things, if we take it separately, it is just simply addition of scalar power.
So power is dot V. So energy is acting in the downward direction.
You can do like this. Okay. See, power is equal to R into V. Okay, you are saying like if this okay, you are saying like this mg is acting in the downward direction, so this will be dot V, so this entire term will become 0. Oh, right, fine. Okay, so that is a genuine doubt. Let me check. Okay, this one clear? Okay, fine. Let me see. 220. In other way also we are getting the answer as 220. How much is the answer for this one? Okay, this is 20. So otherwise the answer is getting as 220. Okay, mark this question. We have doubt here. We will discuss this later. Okay. Question is like even if we take power, if we take dot product of this one, then how it becomes non-zero? That is the question. Okay, so we will discuss that later. Okay. Okay children, see, now one more thing regarding this power is efficiency. Okay, efficiency. Efficiency. Efficiency is to what? Output power divided by input power. So if it is in percentage, we will be multiplying with 100. Okay, output power divided by input power. See children, this output power is actually any useful work. If you are pumping water to the tank, that is a useful work. For that, what input we are giving? If we are giving electrical input, then that will be input power will be electrical power, the output power will be that mgh. Okay, so this output power is any useful work which we are intending. Clear? Okay, let it be there. Now come to which question children? Question number 68. Okay, two men with weights in the ratio 5:3 run up a staircase in times in the ratio 11:9. The ratio of power of the first to the second. Question number 68. A. Okay, so P is equal to what? mgh divided by time t. So what? Okay, weights are in the ratio 5:3. So P1 by P2 is equal to they run up a staircase in the times in the ratio 11/9. So this is equal to m1 by m2 into T2 by T1. So mass is in the ratio this is how it will come, 5/3 into 9/11. So this is going to be 45 divided by 33, we can say 15/11. 15/11. Option A. Option A. previous question, this one, what Preeta and Dharini said is correct. See, this is the answer for this question. Question number 61, children. I did a mistake. 67. P is resistance force into mg into velocity. This into velocity. That's it. Resistance force actually. So children who are watching online, I am revisiting to question number 67. The solution which we were doing in question number 67 was wrong. Okay, so we are revisiting to that. Okay, please note of this question number 67 in the handout. See children, R is equal to 10% of the weight. So how much is the weight? How much was the weight we calculated? 10 raised to 5. 100 quintals mg is equal to into 10 raised to 5. Now 10% of this is going to be 10 by 100 into 10 raised to 5, cancel, we will be getting 10 raised to 4. Now we need to consider only R here. So power is equal to R, that is the resistance of the rod or resistance of the air, only that we need to cancel. So this is going to be 10 raised to 4 into what is the velocity, children? 72 into 5 by 18. So this is going to be, okay, this is going to be 20. So 20 into 10 raised to 4, we will be getting 200 kilowatt. Then this is correct. Okay, fine. Okay, which option? D option. Okay, Dharini and Preeta, thank you so much. Okay, clear? Understood or what? Purila. MG why MG is not taken? Why the weight of the thing is not taken? See, why weight is taken? See, the previously we have written like R plus ma when the acceleration direction was in this direction. If the vehicle is moving in this direction, then we can take this one. But the problem is when we try to consider mg, power is equal to force dot velocity. If the velocity is in this direction, mg is in this direction, then mg dot v is nothing but mg v cos 90. This is going to be 0. Clear or what? So always force we can take like this. Clear? Understood? Okay. Thank you so much for notifying this. Okay children, next question, last one. Which is the last one? So this is done, right? Okay, one more question is there, 69. Again we have to do some more problems on power, then we will start collision. So we will stop here. Okay, then thank you so much.